Gasoline. Powerful stuff. Modern magic. Our lives, our business, our cities are patterned on motor transportation which gasoline has made possible. Do you realize what gasoline means to this country? It has added a new freedom to our lives, the freedom of movement, of individual transportation, anywhere, anytime, for everybody in America. And those who make and sell gasoline perform a service, not only to their communities, but to the whole country. But most people just don't realize how much hard work, knowledge, and money it takes before gasoline can come out of a pump and into the tank of an automobile. First, there is the search to find the crude oil that's needed to make gasoline, and that takes plenty of study and special training. They send out crews to make surveys of territories that seem promising, just like prospecting for gold in the old days. Only these men are scientists. They sink test holes and use super-sensitive instruments to find out what the Earth is like far below the surface. If the experts decide the results show the possibility of oil, they are ready for the next step. Usually, they first drill a hole to get actual samples of the Earth itself, cores that show exactly what the Earth is like at different levels. The oil engineers can tell if these samples come from a place that contains crude oil, how good it is, and how much there is. Then another big, tough, expensive job gets underway. Clearing the land for drilling, maybe even building roads through wild, rough country. Oil drilling goes on all the time. Thousands of new wells are drilled every year. And because of the scientific way they go about it today, over half of these new wells deliver oil. Next, there's the job of getting this crude oil from the wells to the refineries. A lot of it travels through pipes, thousands of miles of pipes. Some pipelines extend halfway across the country. And plenty of crude oil is carried in tankers. They also transport finished gasoline to every part of the world. These tankers form one of the biggest merchant fleets we have. And the railroads. They carry oil from the gathering tanks to the refineries, and then gasoline from the refineries to distribution points all over America. The process of refining crude oil into gasoline and other products is another big part of a big industry. It takes millions and millions of dollars worth of equipment to turn out finished petroleum products. It's a complicated process, but not at all difficult to understand when you realize that every drop of crude oil is a mixture of many small particles or molecules. They're called hydrocarbons because they are compounds containing only hydrogen and carbon. The molecules vary in relative size and weight. The large, heavy molecules are found in the heavier oils, the fuel oils, lubricating oils, tar, asphalt, and so on. In what you might call the medium sizes, you find smaller and lighter molecules. And these are what are used for gasoline and kerosene and similar products. The very small and very light molecules are the natural gases. As it comes from the well, the crude oil contains molecules of all sizes. The first step is to separate them. The crude oil is heated in a furnace, and the hot oil is pumped into a fractionating tower. The proper temperature is maintained in the tower by recirculating part of the oil through the furnace. The heavy molecules in liquid form concentrate at the bottom of the tower and are drawn off for use as heavy oils. The lighter molecules vaporize, and with the natural gases, move to the top of the column. This mixture of gases and oil vapors flows into a condenser. The vapors condense into liquid gasoline. The next step is to separate the gases from the gasoline. This is done in a second fractionating tower. The gases move to the top of the tower and are drawn off. The liquid gasoline concentrates at the bottom of the tower. This is what we call straight-run gasoline. In the early days of the automobile, this straight run was the only kind of gasoline we had. But as public demand increased, new ways had to be found to get more gasoline from a given amount of crude oil. So the oil industry developed what is called the thermal cracking process. Certain of the larger molecules of heavy oil are literally cracked into smaller molecules in or near the gasoline range. In the fractionating tower, the oil molecules tend to collect at various levels according to their size. That's why they call it a fractionating tower. The molecules collect in groups or fractions. This makes it easy to take off the group of medium weight molecules that are best suited for use as cracking stock. These molecules are piped to a thermal cracking furnace, where by heat and pressure, they are cracked into smaller molecules. At the same time, a lot of other things happen to the chemical structure of the molecules, and a kind of synthetic crude oil results, with molecules of all sizes, but almost half of them are in the gasoline range. This goes into a flash tower where the smaller molecules vaporize. Those that are too heavy are drawn off and used as asphalt, coke, tar, and so on. The lighter molecules move to the top of the tower and then to a condenser where they again become liquid. To separate them, they go to another fractionating tower. The heavier oil collects at the bottom and is drawn off as cracked fuel oil. The lighter molecules move toward the top, condense, and are taken off at their proper level as thermally cracked gasoline. The gases formed during the cracking process move to the extreme top of the tower and are piped off. Also, to obtain more gasoline, some of the cracked fuel oil is piped back to the thermal cracking furnace and goes through a second cracking process, again increasing the amount of gasoline obtained from a given quantity of crude oil. In recent years, the industry has tremendously expanded a comparatively new cracking process called catalytic cracking. A catalyst is a substance which causes a desired reaction to take place without being affected itself. In cracking gasoline, the catalyst is in the form of beads or a fine powder-like material. In this process, heavier molecules of oil below the gasoline range are piped into a furnace and heated. The hot oil vapors then go into the catalyst tower, where they contact the catalyst. This not only cracks the molecules down to smaller size, but changes their chemical structure to make them suitable for gasoline. These smaller molecules then go to a condenser, where they become liquid, and then to a fractionating tower. Again, the liquid that is too heavy for gasoline collects at the bottom and is drawn off as cracked fuel oil. Gasoline is drawn off at its proper level, and this is what we call catalytically cracked gasoline. In many operations, even more gasoline is obtained by sending some of the catalytically cracked fuel oil into the thermal cracking process. The gases, as usual, collect at the top and are piped off. In every process, gases have been produced. These used to be burned away as waste or used as gas. But to conserve our natural resources and to obtain the largest possible amount of gasoline from the crude oil, the oil industry discovered how to make gasoline from some of these gases too, by a process of polymerization. This is just the reverse of cracking. Polymerization simply means combining very small molecules to form larger molecules. So the smaller molecules that are lighter than gasoline are combined into larger molecules from which gasoline can be made. The gas is piped into a furnace and heated. The hot gas goes to a catalyst tower. By contact with a suitable catalyst, usually phosphoric acid, a chemical reaction occurs which causes the molecules to unite and form larger molecules. These larger molecules go into a fractionating tower. Those in the gasoline range condense to liquid, and this is drawn off as polymer gasoline. Those that are still too light are drawn off the top as fuel gas. So we have four main types of gasoline refining processes. Straight run, in which gasoline is vaporized from crude oil by simple heating. Thermal cracking, in which heat and pressure are used to split heavy oil molecules into smaller molecules suitable for gasoline, catalytic cracking, in which a catalyst is used to split heavier oil molecules, and the polymer process, in which small gas molecules are combined to form larger molecules and condensed to liquid. Certain of these processes produce gasolines of superior anti-knock quality. Gasolines from other processes can be stepped up by blending with materials such as alkylate or benzol. Most refiners, however, find it advantageous to add ethyl brand of anti-knock compound to their gasolines. It ensures high anti-knock quality for their entire output. For more than 20 years, ethyl brand of anti-knock compound has helped the petroleum industry to bring out better and better gasoline. And during these past years, you have seen what better gasoline has meant in producing better automobiles with engines that give increasingly better power and better performance. This progress is the result of the constant endeavor of the oil and automotive companies to fit engines to fuels and fuels to engines, an endeavor in which ethyl research engineers, today as in years past, are working in close cooperation with both industries. And as our progressive American oil industry, with research and ingenuity, continues to improve gasoline, automotive engineers will design new and better engines capable of converting this extra available power into greater efficiency, more economy, faster, smoother, more resilient power on the highway, on the farm, in the air, and on the water. For this is the age of motor transportation, with gasoline for everybody.
The flash of power, the gleam of oil. In the sky, the power of oil conquering the heights. On the sea, the might of petroleum pulsing in great engines of the liners that traverse the deep. On land, oil feeds the fiery furnace or drives the diesel engines along far-flung rails of steel. And on the open road, well, you know what makes your auto run. For millions of years, this source of power slept peacefully in the dark recesses of the earth until modern magic loosed the liquid energy from its subterranean prison. Great areas became forests of towering derricks. And here's how the petroleum forest grows. A cellar is dug, and a rotary table to turn the drilling stem and the bit is set in place. Round and round the rotary goes, drilling deep down to oil. A steam engine drives the drilling mechanism. They're inserting a length of pipe, lengthening out the stem for deeper drilling. A new joint is waiting. Oil field workers are called drillers, roughnecks, roustabouts, rope chokers. The oil field treats our ears to odd and colorful names. Now the drilling stem has been lengthened. Then round and round once more. Down through layers of sandstone, shale, limestone, down to astonishing depths. This well 5,000 feet. Some 10,000, 2 miles into the earth. And then, after weeks of drilling, fighting against natural obstacles, the drill at last reaches the oil sand, porous rock, which holds the oil much as a sponge holds water. Next, the casing is lowered to the bottom of the hole and cemented in position. Then drilled through the oil sand, and a screen is installed at the base of the casing. The screen extends down into the oil sand. The oil flows through the screen, up through the small pipe tubing to the surface. So they've struck oil, and now the well must be cleaned of the mixture of drill mud and oil. Some wells flow of their own pressure. Others must be pumped, need power. The power is transmitted to groups of wells, the ever-swaying rocker arm, the rhythm of pumping, the unceasing heartbeat of the oil fields. A 24-well hookup is the height of oil field power. Pumping black magic from 24 drillings in the earth, all at the same time, out of the ground. The oil is cleaned of natural gas or water, which is combined with it. Next, the petroleum starts on its way through a great network of pipelines. There are powerful pumping stations every 40 or 50 miles to keep it moving along the lines. The lines of pipe, alive with racing oil, run through forests and over plains to these silver discs. They're storage tanks where the oil rests briefly before it rides the waves in giant tankers. And they're masterpieces of shipbuilding, those tankers of steel. The largest navigate the sea at 15 knots and carry 5.5 million gallons of oil. The voyage of oil to the refineries. The refinery with its modern structures, technological towers, minarets of science, docks, office buildings, pageant of industry. Day after day, there is an endless flow of oil as the tankers discharge their liquid cargo. Unloading oil is a vast operation of piping through huge hoses. Discharge pipes on the vessel and receiving lines on the dock are connected, and a cargo of 5 million gallons is discharged in less than 24 hours. No two cargoes of crude oil are alike, so each boatload must be stored in different tanks, and each batch must be processed individually with laboratory tests to indicate the precise treatment for each. That is embodied science. Those masses of strangely wrought steel, forests of stacks, glowering and hissing boilers, leaping and winking fireboxes. Intense heat, the flames roar in the furnace, yet the oil flows so fast the heat does not scorch it. And scientists wrest from the crude petroleum its tremendous power in the form of gasoline and other fuel oils. And that's done in these towers called fractionating towers. They divide crude oil into the lighter and heavier parts. Those of different boiling points liquefy at different levels in the towers. Some lighter than gasoline liquefy at the top. Heavier parts liquefy further down. At the bottom are the heavy fuel oils, or the raw materials from which lubricating oils are made. When increasing use of motor cars pyramided the demand for gasoline to extraordinary heights, scientists were called upon to devise new methods. How could a greater proportion of gasoline be extracted from the crude oil than that obtained from the fractionating tower alone? To meet this challenge, the scientists turned to products other than gasoline which are drawn from the crude, studied their molecules, and found a way to change them, to turn them into gasoline. The result was cracking. Let's look at a diagram of a cracking plant. Here we see how one part of petroleum that is not gasoline is converted into gasoline. Called gas oil, it is pumped through a pipe into a cracking furnace, heated to over 900 degrees under tremendous pressure. And the individual particles, molecules, are broken into smaller molecules, just as coal is broken under a hammer. If we could see one of those molecules, it would look something like this. The hotter the molecule gets, the faster it wiggles, until finally it wiggles so fast it flies apart. The pieces shoot around at great speeds. They eventually find partners and form new and smaller molecules that look something like this. These smaller molecules are now no longer gas oil, but are gasoline of high-powered, knockless quality. Some of the gas oil molecules do not fly apart and must be separated from the gasoline. This is done in the bubble tower. Here the big molecules, which are not gasoline, are held back and come out at the bottom as a liquid. The gasoline goes up the tower as a vapor, comes out at the top, and is condensed into liquid gasoline. Gasoline that gives more power to you. Experiment is the key to it all, and this is the experimental laboratory. In the making of powerful motor fuel, the control of temperatures is of extreme importance, and it is measured to an accuracy of 1/100th part of 1 degree. Gasoline is broken down into over 200 parts in that elongated tallness of glass, and each individual part is studied. The laboratory with its strange gleaming of new and unpredictable things. Here are created modern miracles with the chemistry of oil. Tank farm, to which the motor fuel goes from the refinery and then out to the nation by railroad tank car and by motor barge. Pipelines run their web-like nets under rivers, over mountains, carrying gasoline that goes into millions of gasoline tanks to generate billions of horsepower for the nation. Oil means horsepower in a horsepower-using world. Briefly, in 4 words, more power to you.
Oil is found in only a few hills and valleys throughout the world, mainly in the United States, Canada, and Mexico, in Peru and Venezuela, in the Balkans, along the Persian Gulf, and in the Dutch East Indies. Over half the oil that has been produced in the whole world was produced in the United States, mainly in the states of Texas, California, Louisiana, and Oklahoma. The story of how oil is brought up from far down in the earth is exciting. The products of oil or petroleum are necessary for us to live the way we do today. We need gasoline to run our automobiles and airplanes, fuel oil to run our modern trains, kerosene to heat our houses, and of course we need the oils that keep our powerful machines running. Bob Gaffner lives near the oil fields and likes to watch the men drill for oil. The high towers or derricks are needed to lift the long lengths of pipe over the wells. Here, the men are lowering the drill pipe into the well. They swing another length into position and screw it to the top of the last length of pipe that was lowered. The men use a large wrench called a tong to screw the lengths of pipe together. The pipe is slowly lowered into the well by the large yellow pulley or block. As the hole becomes deeper, more lengths of pipe are added at the top. They drill deep enough to find the oil deposits. The men make frequent tests to find out which layer of rock or sand contains the most oil. Formerly, oil drilling was a gamble. Many fortunes were made and lost. It is still a hazardous occupation, but with modern scientific methods for finding the oil and with the improved drilling machinery, there is a far greater chance for success when they drill. Bob asks why the men wear metal hats. Well, that's easy. Tools might be dropped accidentally by the men who work at the top of the derrick. The hole is actually drilled by a square pipe called a Kelly that is always fastened on the top of the drill pipe. The Kelly fits into a strong table that is turned round and round by powerful engines. This turns the drill at the bottom of the well. As the hole becomes deeper, more drill pipes are added. The piece of machinery that digs the hole at the bottom of the drill pipe is the bit. Jerry shows Bob a bit. The sets of teeth turn round and round to dig the hole, just like claws. It is said that oil hunters never can be sure of a strike until the bit cuts into the oil sand or oil rock. Notice the large center hole. Mud and water are washed with great force from the top of the Kelly down the center of the pipes through this hole in the bit. The water and mud clean off the teeth of the bit and contain chemicals that make the mud in the hole form a hard crust that seals up the hole. This prevents cave-ins and keeps the water and gas in the different layers of earth from pouring into the well and stopping it up. Notice how clean the engines are. When the men have finished drilling a section of the well, they build the permanent well to this depth. The permanent well is made out of heavy pipes called casing. Thus, they alternate the drilling and the laying of the permanent pipe. The lengths of pipe are screwed together with a tongue in the same way that the drill pipes are screwed together. The men step back out of the way of the machinery to avoid accidents. And now the large pipe goes down. Just think, sometimes these pipes go 3 miles down into the ground. When they have finished drilling the well, they place a small pipe called tubing inside the heavy casing, and this small pipe carries the oil to the surface. At the bottom of the well, gas and rock pressure force the oil out of the sand and porous rock and into the tubing. A high tower called a mast is used to lift the small tubing over the well. The derrick man at the top of the mast fastens the tubing in the block and swings it over the well. The men screw the length of tubing together and signal the driller who runs the engine to lower it into the well. When the well is drilled, the pump will be put in position on top. The Long Beach oil fields have produced millions of barrels of oil. These pumps are modern and up to date. They go up and down, perhaps bringing a fortune to the people who own them. The wells look like a row of animals nodding. And yes, the part that bows really is called a horse's head. And the cross rod that goes up and down like a teeter-totter is called a pony rod. On the opposite side from the head is the counterbalance. Bob looks at the oil pressure gauge that is watched carefully by the men who service the wells. It shows the men that the oil well is producing. At this well, the valuable oil is leaking, and the repair crew must find the trouble. They're good mechanics, and soon the well will be working. No one knows exactly how oil is made. It is generally thought that plant and animal life, buried far down in the earth in vast prehistoric seas, was changed slowly into oil, probably by pressure, heat, and the decaying of the tiny plant and animal life. They say that Texas, our greatest oil-producing state, literally rests on an ocean of oil. The men paint the pumps often to protect them from dirt and water. Eric wears a mask so that he will not breathe the poison fumes from the paint. The wet gas that comes up with the oil sometimes is run off at the wells. You can see the gas tanks or traps at the wells and at the field storage tanks. Waste water also comes up with the oil and is removed at the field storage tanks. These 3 boilers heat the oil so that it will float on top of the water, and the men can remove the water from the bottom of the tanks. Here the oil is pumped from the field tanks to the refineries with their huge storage tanks. Sometimes the crude oil is carried in pipes across several states to the refineries. For example, a pipeline carries oil from Texas all the way to New York. The crude oil also is carried to the refineries by train, by ship, and by tank trucks. Crude oil must be changed at the refineries into the products we use. The wind is blowing a terrific gale, and Bob is amazed that the men can work high up in the derrick. They are taking the derrick apart to move it to another location. They unbolt the different sections and lower each section separately. The men are skilled to work high up on the narrow beams. Oil men must be strong to operate the heavy machinery. They must think accurately in the midst of noise and confusion. Their very lives depend on each man's cooperating and doing his part well. The men walk on the narrow ledges as unconcernedly as if they were walking on the ground. The pay in the oil fields is high and attracts many smart and well-educated men. And now the ground crew pull together to guide the heavy section as it is lowered slowly to the ground. Men who cannot keep up with the difficult work soon drift to other occupations. The man on the truck operates the engine that runs the lines. They unscrew the bolts on another section. This well produces a large quantity of oil, and the men will replace the old pump with a modern one. And down comes another section. They wind up the long lengths of line. Many different tools are used in drilling. They are always kept in order, ready for the next job. There is a special place on the truck for each part of the machinery. Bob hears the fire engines. Better hurry. What's that? An oil well burning. Just think, right on the ocean beach. Thousands of dollars worth of oil burning up. The men fear the whole oil field will catch fire, and they are working desperately to prevent more loss. Large fire trucks stand in line to take turns pouring chemicals on the flames. The fire finally was put out by pouring water from the well next to it into the bottom of the well. This meant the temporary loss of the other well, but prevented the fire from spreading to the rest of the field. Oil is one of our most important natural resources, and it is necessary to be careful of our supply and save it in every way we can. Bob understands now that there is great danger of fire in the oil industry. Every fire precaution is taken on the docks, where the drums of oil are stored for shipment to the countries that need oil. There are many large countries, like France and Germany, that do not have oil and must ship it in from the oil-producing countries. England does not have oil, but the British Empire controls many of the foreign oil fields. There is oil in Canada. The Americans, the English, and the Dutch have found and produced most of the oil in the world. Bob likes to ask the oil man questions about oil. Here the longshoremen are loading a freighter bound for France. Oil is the largest export from the ports of Long Beach and Los Angeles. They ship oil to Oregon, Washington, Hawaii, and the Orient. $200 million worth a year. Bob thinks the oil drums look like bright colored toys. He would like to try to ride one of the rolling drums. Four drums are hoisted onto the ship at one time. Each load is counted twice. First on the dock by a checker from the oil company, and again on board by a ship's officer. Thus the companies buying and selling the oil both have a record of the oil shipped. Just think, in 1 year, the United States produces over $3 billion worth of oil. Well, Bob thinks this cable spool looks like an oil drum. Well, he can try to ride it. Hey, careful there, fella. Steady now. Hey, that's pretty good. It's like a circus. Whoop, whoop, take it easy. Yes, sir, he's just like a circus performer. That looks like a lot of fun, Bob. A large tanker steams into port. Today, many hundreds of oil tankers carry oil from wells to the markets of the world. These large tankers carry around 130,000 barrels of oil. The tankers refuel from the large hoses on the docks. The hose is swung onto the ship, and the oil flows directly into the tanks in the ship. The flow of oil is controlled by large valves on the ship and on the dock. Oil ships are built with rows of tanks on each side. Thus, when the ship rolls, the oil will not all shift to one side and capsize the ship. Down the center is the catwalk. The crew can walk from the bow to the stern without getting wet when the waves roll over the deck. The cover is raised over one tank that is being filled. The men watch the oil gauge to see when the tank is full. Oil companies maintain large plants with storage tanks at the docks. 1 million men work in the oil industry. In front of the freighter, an oil barge is loading. These barges carry oil to the ships. Often, they refuel the ships at their own docks, but sometimes the barges refuel ships far out in the bay. When a ship drops anchor in the harbor and refuels there, she is said to be at bunkers. Oil is piped through the heavy hoses from the barge to the ship. If the ship does not have cargo or passengers for the port, It saves time and money to refuel at bunkers. Across the channel, Bob sees a wrecked oil tanker that burned at the dock. It is too soon for the salvage crews to enter the ship because there is still oil in the hull that might explode. No one knows what caused the terrible explosion. Many were killed instantly. Others had to dive into the water covered with flaming oil and swim underwater to safety. Just think, one match thrown carelessly away could have caused this huge explosion. We understand now why the oil docks are built away from the mainland and why the refineries are built away from the docks. Near his home, Bob likes to stop by the garage and watch the men work on their cars. Bill, the mechanic, tells the boys how he fixed the broken oil line caused by a bad bump. Bob's friend works here after school and on Saturdays. Bob wishes he knew as much as Teddy about a car. Teddy checks the oil and adds a quart. Oil is mighty important in keeping an automobile running smoothly. As gasoline, it is needed as fuel for the engine, and as grease for many purposes, just as it is needed to keep the machinery running in our big industrial plants. The silver towers that make the refineries look like fairyland castles really are places where the oil products are made. The crude oil in the towers is heated by steam, which is piped to the top of the towers. The different degrees of heat and pressure break up the crude oil into many different products. The lighter products go to the top of the towers. Gasoline is the lightest and can be run off the top. Next is kerosene, and so on down the length of the tower. Bob tries to understand what oil means to us today. Why, oil changes miraculously into power. Power to run the giant plants that make the things we need and use. Power to speed our modern trains, ships, airplanes, and automobiles. Oil is a great industry, supplying the needs of people throughout the world.
Progress Parade brings you a collection of true stories of America at work. Fishing on dry land? What kind of a fish story is this? Yet it happens all the time wherever oil wells are drilled. As far as this drilling rig is concerned, everything seems to be operating smoothly. That's trouble. The trouble is 2 miles straight down. Down at the bottom of the drill hole, 10,000 feet below the surface, the drill pipe has broken off close to the drill bit. The broken pipe with a bit now has to be fished out of the drill hole. And so they send for a specialist they call a fisherman. Meanwhile, the drilling pipe above the break, all 10,000 feet of it, must be removed, disconnected, and stacked aside. Whenever a broken pipe, drill bit, or anything else is lost down in the drill hole, it is nicknamed the fish. With the arrival of the fisherman, a specialist who makes his living by fishing in drill holes, a most unusual operation begins. The fisherman sizes up the only evidence available, the jagged edge of the broken drill pipe. He can't predict whether it'll take 2 days or 2 weeks, or even if he can catch the fish. But fish he will. It's that kind of a job. Three days and many fishing attempts later, they try another special fishing tool. Maybe this one will work, but they have no way of being certain. The trick is to make sure the tool is lowered the 2 miles directly over the fish. Down it goes in the end of 10,000 feet of pipe, expertly manipulated by the fisherman who has tons of massive machinery and equipment at his command. When he has the tool 2 miles down, he feels his way carefully, cautiously. He uses the gauges as his eyes, experience as his guide. Down, down it goes over the stuck fish until there it is, caught 2 miles underground. But will the tool hold the fish all the way up? Here's the payoff. Yes, the fish is caught. Our dry land fisherman has saved this $100,000 drilling investment. Now the drilling can continue to see if it strikes oil. Baby demands comfort, all right, and if he doesn't get it, a formal protest is soon registered. Every baby is a born expert as far as knowing what's good for him. He approves only the most gentle products expressly prepared for his well-being. Baby oil, for example. It is so pure and mild that during the infant period, it is often used instead of water for his bath. Who would think that from this crude oil, pure baby oil is refined? But to extract baby oil and the hundreds of other useful products from petroleum after it is taken out of the ground requires as many as 10 different refining processes. A fantastic amount of investment, equipment, scientific skill, and complex engineering. Competing oil companies spend over $150 million every year in progressive research just to develop and improve new products from petroleum for baby and the rest of us. Whenever a liquid boils, you just naturally think that it's hot. But this liquid can't be hot. It's sitting on a cake of ice, boiling on ice and vaporizing, producing a gas that burns. This unusual liquid is LP gas, one of the hundreds of products from petroleum. In many homes, it is one of our most useful handymen. It cooks our food, heats our water and our home. For the farmer, it can generate his power, warm his chicks, fuel his tractor, and control weeds through flame cultivation. And what of industrial uses? Well, LP gas serves, among other things, textile industries through drying processes. It can operate that workhorse of the factory, the forklift truck. And heat treat metals for 1,000 industrial uses. LP gas prevents railroad switches from freezing and thus keeps the trains running. One important use is providing the cooking fuel for restaurants throughout the nation. Last year, 6 billion gallons of LP gas were transported and sold in the United States. Now, how would you transport this liquid fuel that boils well below the freezing point of water? The oil companies solved the problem by developing specially built tank cars and tank trucks permitting LP gas to be handled and stored in liquid form. 1 cubic foot of this amazing liquid becomes 300 cubic feet of vapor, which will do the work of 750 cubic feet of natural gas. A major achievement of the competing oil companies has been the development of techniques for successfully transporting and handling liquid fuel in great volume and at low cost. Here's a man who wears 2 hats. Of course, he's only wearing 1 hat now. That familiar one you see every time you drive into your neighborhood service station. Perhaps you've already found out he's one of the most conscientious citizens of your town. In addition to his regular occupation, he may be also a member of one of the reserve components of the armed forces. Another service station dealer might be a member of your local civil defense organization, or one of those fire eaters on the volunteer fire department. Perhaps your dealer is an unpaid member of the Board of Education, or serves on the advisory committee for civic improvement. Foreigners touring our country have commented many times that service station dealers are the most American Americans they meet. They say the dealers are cheerful and efficient. They reflect the freedom of opportunity we cherish so highly. That's why we say your neighborhood service station dealer is truly a man who is qualified to wear 2 hats. Here are some sick oysters. Just what made them sick and just how they are to be cured are questions that stumped an entire oyster industry. The trouble started down in Louisiana on the Gulf of Mexico, where the Louisiana oyster fishermen claimed that oil production was killing off the local oyster population. The oil companies didn't agree, but they decided to look into the matter. So they started what developed into a $2 million oyster research program. Scientists went out to the bedding grounds where they collected buckets full of oysters and then brought them to a special oyster research center of Texas A&M College, one of the laboratories established for the oyster survey by the oil companies. In the research laboratory, every type of condition is created for the oyster patients. A blanket of crude oil is poured directly on the water. Water is jetted through oil for 6 months. Oil drilling mud was emptied into the water. Even dynamite charges were exploded near test oyster beds. Every possibility was explored. After years of study and progress, the results were in. The test oysters showed no ill effects from oil, even under conditions which far exceeded those ever present during oil production. As a matter of fact, the test oysters were so happy, they brought forth new generations to share their lot. They never had it so good. Well then, if this wasn't killing the oysters, what was? It took time and money to find out, and the scientists continued their progress. Oyster tissues were prepared for intensified examination and study. No possibility was overlooked. Finally, the real enemies are isolated. The most vicious villain of the lot is Dermocystidium marinum, a species of fungus that is bent on destroying the Louisiana oyster. It was further found that natural changes in the Gulf Coast And man-made improvements such as levees, together with climatic changes, were seriously affecting the proper mixture of fresh and salt water in the oyster bedding grounds. All of these factors were contributing to the reduction of oyster populations. Now that the true causes were known, action could be taken. These major conclusions of the Oyster Research Program are cheerfully turned over to the oyster industry. Why, you may ask? Why were the results of $2 million worth of research given to the oyster industry? It's because oil companies believe that maintaining good neighbors is just good business. As long as business and industry are free to lend a helping hand to each other, then everyone benefits.
We take you now to the Chrysler Building in New York City, to the office of the president of the Texas Company, Mr. Augustus C. Long.
As you good dealers probably know, I've spent a good many years in my life with Texaco in the domestic sales department. I have always enjoyed attending dealer meetings, and I only wish that I could be with you today. I'm sure you realize why this is impossible, as we are holding more than 700 such meetings all over the country. Many of you can remember when in 1938 we introduced Sky Chief gasoline. It was the gasoline for the motorists who wanted the best. In the years since 1938, we have never let you down in that we have kept the quality of Sky Chief at all times ahead of competition. However, realizing the tremendous development that is taking place in automotive engineering, we have had our technical people busy working on a brand new gasoline, a revolutionary gasoline that will do more than any gasoline has ever done before. We are happy to tell you that we have succeeded, and our new Sky Chief gasoline is either available to you or will be available soon. This new top octane Sky Chief gasoline is not just another gasoline. It is a result of the combined efforts of many men and the expenditure of many millions of dollars. We honestly believe that top octane Sky Chief supercharged with Petrox is the biggest thing that has hit the industry in a long, long time. And we're going to do everything in our power to let the public know about it. After that, it's up to you. In a moment, some of our technical people will tell you more about this new gasoline supercharged with Petrox. And when they have told their story, I think you will agree that it's going to be easy to sell more in 1954. Good luck to you all, and thanks for the privilege of talking to you about this great new gasoline. It's yours exclusively.
And now we take you to one of our research centers, our Beacon Laboratories, and to Dr. W.E. Kuhn, manager of the Technical and Research Division.
The first thing that every Texaco dealer asks about our new gasoline is, what is Petrox? Well, here's what it looks like. Petrox is a new element, or an additive if you prefer. We are putting it into a greatly improved gasoline. You men who understand engines will appreciate the fact that Petrox is an additive derived entirely from petroleum, which is something brand new and exclusive with Texaco. It is the only such additive being used by any oil company. The fact that it is derived entirely from petroleum is important because it doesn't contain anything that can leave harmful engine deposits, since it doesn't come from an inorganic source. Petrox is a Texaco discovery, which I might add, didn't come overnight, but is the result of years of research and more than 1 million miles of testing. We don't buy it from any chemical company. It's made only by Texaco. In fact, we built a special new plant at Port Arthur to make it. That means it's yours exclusively. It would take hours to tell you the whole story, but Phil Foster here is going to give you some of the highlights that will tell you why this year you're selling the finest gasoline that's made.
You know, this oil business is highly competitive. A lot of oil companies say their gasolines give easy starting, fast warm-up, quick acceleration, no vapor lock, no knocking. Some say no stalling, power and economy. With climate control, there isn't a gasoline on the market today that can beat the old Sky Chief. So I won't take the time to tell you how good the new top octane Sky Chief is on any of these counts. It's better, believe me. But there are things our new gasoline does have that no other gasoline ever dared to claim. Before I tell you what they are, I'd like to show you on this cutaway engine what the problem is. You all know that inside the cylinder, you have 4 strokes of your piston. Intake, compression, power, and exhaust. Intake, compression, power, and exhaust. The whole secret of engine power is right here in this area where the explosion takes place. If this area is completely sealed in, you get the full force of the explosion on the piston, and you get the maximum power of the engine. But, and here's the catch, if there's any leakage here, you don't get the full force of the explosion, and so you lose power. Now, there are 3 places where you can get leakage. Around the piston rings, around the intake valve, and around the exhaust valve. And the things that cause leakage and loss of power are deposits and wear. And that's where we come into the picture. Texaco dealers can make the claim and prove it that they have a gasoline that keeps an engine cleaner. Gasoline is a natural dirtier of engines because there are byproducts of combustion that build up deposits on engine parts. We have run over 1 million miles of road tests, and we have demonstrated conclusively that top octane Sky Chief, supercharged with Petrox, does not dirty up engines. Here are some charts of the test results. Intake manifold cleanliness, intake system cleanliness, spark plug cleanliness, combustion chamber cleanliness, condition of exhaust valve seats, intake port cleanliness. These are actual results of many thousands of miles of road tests. But they're probably not as convincing as these actual engine parts. Look at these valves. This one used top octane Sky Chief, and this one used a competitive premium gasoline. And look at these spark plugs. This one used top octane Sky Chief, and this one used a highly advertised competitive premium gasoline. Spark plug life and efficiency increased more than 300% on test engines. Your customers may ask, why is it so important to keep an engine clean? The answer is to keep it young. You buy a new car, and it has a certain amount of power. Then as you drive it, engine deposits start building up. This makes your engine cry for more octane in the gasoline. And if it doesn't get it, you lose power. If you keep your engine clean, you go right on getting the same power you had when the car was new. And along with that power, you get fuel economy. New Sky Chief with Petrox not only reduces the octane appetite of your car, it provides octanes which are appreciated by your engine, thereby giving unusual, knock-free performance. This chart shows the results of our short-trip stop-and-go driving tests. It shows a saving in gasoline consumption of 5%. That means a saving in this test of 1 gallon out of every 20-gallon tank full of gasoline. This clean engine quality of top octane Sky Chief, as I said before, is an exclusive with Texaco dealers. The most spectacular feature of the new Sky Chief is this. Reduces wear. We showed you in a film tonight that advanced custom-made Haviland does a remarkable job of reducing wear. We did not think it possible to reduce wear beyond this point. We now know and can prove that top octane Sky Chief reduces wear still further in these very critical areas. And that means even longer engine life. You have a perfect pair. The first team, the best motor oil, and the finest gasoline that money can buy. They were not born. They are made for those who want the best. Look at that chart. It compares ring wear in the cars using top octane Sky Chief and those using other premium gasolines. There's an improvement there of between 35 and 40%. Petrox is the difference. We did more than 1 million miles of testing of this new gasoline, and we're sure of our ground. With top octane Sky Chief, supercharged with Petrox, every motorist will get maximum power, sustained power, prolonged power, plus economy, less maintenance, and greater mileage.
Yes, it's yours exclusively, and so is the tremendous advertising campaign and the eye-catching point-of-sale material. Here is the first newspaper announcement ad, with many more to follow. Powerful ads like this will appear in the leading national magazines. The big outdoor advertising posters will tell the story to millions of motorists. And now we have a concluding message from Mr. C.B. Barrett, Vice President in charge of sales.
It is a happy privilege for me to have this opportunity to express our appreciation to all of you for being here tonight. Your presence shows that you have a real interest in learning more about the plans, the products, and programs of your company. Several months ago, I called on a number of Texaco dealers in various sections of the country. I wanted to find out firsthand what problems you gentlemen felt were most pressing. I can tell you very simply the gist of what you told me. You expect business to be good in 1954, but you also expect competition to be keener than it has been in recent years. After what you've seen tonight, I believe that you'll agree that your company has recognized this problem and that we're in better position to cope with this competitive situation than we have been in many years. We have a whale of an advertising and sales promotion program. We all got a laugh out of the advertising movie, but let's not forget the serious side of it, which is that we're advertising Texaco products and services so that more people will come into your station and you will have the opportunity to sell more in 54 and enjoy increased profits resulting therefrom. That is what our advertising is for, to bring customers to you. You can benefit further by personal solicitation and follow-up. But once these customers come in, you have a real job to do. Remember the interesting presentations along that line tonight? That registered restroom movie. Take a look, George, certainly points out an important part of station operation. And the feature film, The First Team, again emphasizes the advantages of good business management and a sound, well-planned merchandising program. In advanced custom-made Haviland motor oil, you have a distinct advantage over competition, as this is truly the best motor oil that your money can buy, and is still mighty cheap insurance. As Mr. Long, our president, has already told you, our research department has really come up with a revolutionary new gasoline. Top octane Sky Chief, supercharged with Petrox. This great new gasoline is bound to attract many new customers to your station. Its performance has been spectacular, and I predict that you are going to be surprised at the enthusiastic reports that you get from your customers when they start using it. Now let me sum up this meeting to you tonight, something like this. In top octane Sky Chief supercharged with Petrox and advanced custom-made Haviland, you have the best products on the market, the finest gasoline and the finest motor oil. An unbeatable first team, a team which is bound to boost your prestige and profits, and backed by a tremendous advertising and sales promotion program. The rest is up to you. Competition? Sure. We're going to have very keen competition, but with the best products in the business and the best dealer sales force in the industry, we can't miss. The first team is on the field, and with a proper push and follow-up on your part, I confidently predict that you're going to have the best year in your entire history. Thank you for being here tonight and giving me the opportunity of having a part in your meeting. The best of luck to all of you.